Assalamualaikum and hi everyone. We are from Group 3. Today we are going to present about our first case study for this subject, which is Embedded System Application DJM50122. Our topic for this case study is Interface Microcontroller PIC 16F877A with Servo Motor. My name is Nur Adani binti Ahmad Hisham and my metric number is 01 DEM5A 1022.
Hello, my name is Lo Kai Jian. My matrix number is 01 DEM20F1025.
My name is Sinagi. The metric number is 01DM20F1002.
Hi, Assalamualaikum. My name is Aina Yasmin binti Aziz. My metric number is 01 DEM20F1005.
So now let's move to the first point, which is the introduction. A servo motor is a type of actuator, mostly circular, that allows angular control. A servo motor is an electrical device that is a part of a closed loop system, and it is usually drives a final control element. In servo motor, the term servo stands for the motor operates in a closed loop system that uses feedback from an encoder or resolver. This should compare the motor's actual position, velocity or torque to the commanded value. When we use a DC powered motor, then it is called a DC servo motor, and if it is an AC powered motor, then it is called an AC servo motor. The servo motor has the same construction of the DC motor, and it works on the PWM, which is the pulse width modulation principle. These motors are used to convert electrical signal applied to the angular velocity or movement of the shaft. Next, the type of servo motor. It is classified depending upon the nature of the electric supply to be used for its operation. So basically, these servo motor are divided into two, which is the first one is AC servo motor and DC servo motor. And the DC servo motor also are divided into two, which is the armature controlled DC servo motor and field controlled DC servo motor. An AC servo motor is constructionally similar to a two-phase induction motor. There are two windings that are in the AC servo motor. The first winding is called a control winding, and the other winding is called a reference winding, which is excited by the constant voltage. In between the two windings, the rotor will be connected to the load. Out of two winding places are in quadrature, both are in 90 degrees. The next one is DC servo motor. The DC servo motor behaves like a mechanical transducer that converts DC voltage into mechanical signal, more or less the same as normal DC motor. The control of the DC motor can be from the field side or armature side. Just like what I said before, the DC servo motor are divided into two, and the first one is armature controlled DC servo motor. The armature controlled DC servo motor, the field current is held constant and the armature current is varied to control the torque. And the second one is field controlled DC motor. In the field controlled DC servo motor, the variable input voltage is applied to a field winding and armature current is kept constant.
So what are the applications of servo motor in engineering? Positioning a servo motor mechanism were used in military, fire control and marine navigation equipment. Today, servo mechanisms are used in automatic machine tools, satellite tracking antennas, remote control planes, automatic navigation system on boats and planes, and anti-craft gun control system. Now, what is a servo motor used for? Servo motors has many uses within motion control. They are used in applications to control rotational speed and position as well as output torque.
Thank you. And now I will start with the introduction of microcontroller PIC 16F877A. It is one of the PIC microfamily microcontrollers, which is popular at this moment, start from beginner until a professional. The 16F877A is a capable microcontroller that can do many tasks because it has a large enough programming memory of 8,000 words and 368 bytes of RAM. It is enough to do many different projects. It has 6 40 pins by 33 pairs of input-output. The 40 pins make it easier to use. The peripherals as a function are spread over the pins. So, PIC microcontroller consists of both hardware and software interrupts. If the interrupts are generated by external hardware, at certain piece of microcontroller, or inbuilt device like timer, they are called hardware interrupts. The software interrupts are generated by piece of a part in program, as known as external and internal interrupts. The PIC microcontroller PIC16N877A is one of the most renowned microcontrollers in the industry. The microcontroller is very convenient to use. The coding or programming of the controller is also easier. One of the main advantages is that it can be write-erased as many times as possible because it uses flash memory technology. It has a total number of 40 bits and there are 3 bits for input and output. It is used in many PIC microcontroller projects. It also has much application in digital electronic circuits. So, how many ports it has? It has 5 ports starting from port A to port E. For the port A is for the analog input, B is for the data transmission, C control register, D data port, and also E, the last one, is for the controlling purposes.
Next is the flow chart. So, as you can see, we should start with start, and then we should initialize the input and output. Next, we go to 0 degree and write delay 2000 ms. Next, we move to 90 degrees and write delay 2000 ms. And we continue with 118 degrees with a delay of 2000 ms. And finally, we go to 0 degree back.
Now, let's look at the program and the circuit for our EOC. So this is our program code. Here we will make rotation 0 degree and the rotation 90 degree program. And here is the rotation 180 degree program, and now we will start make the program, which when we start, the servo motor will move from move to 0 degree, and after 2 seconds the servo motor will move to 90 degree. Then after 2 seconds the servo motor will move to 180 degree, and after 2 seconds the servo motor will move back from 180 degree back to 0 degree and repeat it again. And this is the circuit for our EOC. The servo motor is connected to port B, RB0, and the port B is used in data transmission.
Next is result. Individual function for angular rotation of the motor by 0 degree, 90 degree, and 180 degree have been declared in the beginning of the code. In this EOC, we have not used the actual pulse width modulation feature of PIC16F877A to generate a pulse. Instead, the pulse has been created by the help of delays in the program. The delay duration for a particular angle is equivalent to the length of the pulse required for the motor to rotate up to the corresponding angle. That is, for 0 degree angle, the pulse width is approx 800 ms, so a delay of 800 ms is introduced with the port pin RB0 set to high. Similarly, a pulse of 1500 ms is required for a rotation up to 90 degrees and 2200 ms for a 118 degrees angle. In the main program, port B is set as an output port, and all the 3 functions are called separate by a delay of 2000 ms between them. The program calls the motor to rotate in a pattern 0 degree to 90 degree to 180 degree to 0 degree, and so on. The continuous in an infinite do-while loop until the program is aborted.
Last one is the conclusion. In conclusion, a servo motor is a motor that rotates with a high degree of precision. Servo motors frequently have a control circuit that provides feedback on the present position of the motor shaft, allowing them to revolve with great precision. Servo motors are utilized in a variety of industries and offer a number of benefits. As we have already described, these have qualities that make them powerful and efficient, as well as a variety of mechanical solutions. So that's all from us. Thank you.